major levels where through the network we are going to be get. So operating system we are going to be get through the resource sharing we are going to be get and all. Then general maybe physically we are wantonly we done something fault with the system, then we are going to be affected with the virus, all those things. So we are discussing about various things like that, and today we are going to be continuing the same thing with what is cryptography. So in the system security, what how much this cryptography is taking a major role. Mm. So note that so we already discussed yesterday. There are two types of algorithms are there: semantic and asymmetric algorithms. I think you have heard that the symmetric and asymmetric. What is the symmetric? So if you are using uh, the same key in a symmetric algorithm, the different keys you are going to be used in a symmetric algorithm. The different keys are like private key and public key. So where we are going to be use these two different keys and we are performing encryption and decryption according to. Okay. So here I think we continue something I think we have a front one more page. So, like that, okay. So note that a symmetric and asymmetric based on transmissions, symmetric cryptography based on transmission and asymmetric cryptography based on mathematical function. Yes, sir. So there we are going to be generally you can perform encryption and decryption with the key and we are going to be sending. In asymmetric key we are going to be perform some mathematical operations. What is the we are going to be find out take some prime numbers and we are going to be find the mod operation on the prime numbers and we are going to be sending the operation where we are going to be share the uh, different keys in between a sender and receiver. Then how we are going to do. Then asymmetric much more compute intensive. So typically it is not used the bulk data encryption. So if you want to do the bulk thing, so it is unable to perform these mathematical operation also. Is largely it is somewhat difficult to perform. So that is also no? Just we can take a two prime numbers. You need to perform a mod operation, all those things. Then we can send it. So for a simple data, the numbers which we want to send, we are going to use this mathematical operation to compute the small type of data. So if you want to go with the large number of data, then we have the concept of this messageization and hash function. So before going to be this, we can see about this authentication. What is this authentication? The simple meaning that, so for example, if I am going to be created data, so I need to authenticate that it is my data. So myself, I am going to be give an authentication. So constraints a set of potential senders of a message. So constraint is set of potential senders of a message. The message who is created, the sender message, is going to be given authentication. So complementary and sometimes redundant to encryption. They also can provide the message unmodified. So if anything is modification is done, it is easily to identify if this message is modified. So algorithms compute a set of key k of keys, a set of m messages, and a set of a authenticators. Authenticators is nothing but so see that authentication is the process and authenticator is the who is going to be authentication on the message. That is the authenticator. So that is simply who is going to be authenticate the message. The authentication who is done authenticator, that is the sender is. So where we have a function is s equal to, so that is s k tends to m, that is the m message we are going to be do the authentication by the authenticator. So this is each k s of k, each k belongs to capital K. S of k is a function for generating authenticator from message. Both s and s of k for any k should efficiently computable function. Both s and s of k for any k should be efficiently computable functions. Efficiently computable functions. So a function v k tends to m into authenticator either true or false. So when something modification is done, so there we are going to be checking by using a boolean function true or false whether it is done or not. So for each k belongs to k, v of k is function for verifying the authenticator on message. Verifying authenticator on message. So both v and v of k for any k should be efficiently computable function. Efficiently computable function. How we are going to be compute based upon the function k tends to m of m k. How we are going to be do the efficiency. So for each m, a computer can generate an authenticator. So small a belongs to capital A such that b of k of m of a. So that is a message and authenticator. That is true only if possible s of k. That is there is no modification, no changes is happened. Then definitely we are going to be say that the message contains there is no modification. Thus the computer holding s of k can generate the authenticator on message so that they are computing process via k, then verify them. So each and every, so how we are going to be verify the message. So if any modification is done or not, so that we are doing. So computer not holding SRK. Yes or no? Generally, I said that already. The any keys, any so the simple OTPs, any OTPs that is not going to be held by the computers. So computer not holding SRK cannot generate the authenticator message that can be verified by V of K only. Verification only is done. The key is used for the verification only. It is not going to be stored for any more. Since the authenticator are generally exposed, for example, they are not sent on the network with the message themselves. They must they must not feasible to deserve S of K sender of keys from the authenticator. The sender can have an authenticator on that particular key. Then only he can send and he can verify it in the other systems, other end. So for this, if authentication is there, so we are just simply saying that we are going to be do the verification. We have check it via K, and if the sender is creating a key, that is the sender is sending a key, and verifier is in verifying process, we are going to be verify that particular. Then what is a hash function? So basis of authentication, create a small and fixed size block of data. Create small, fixed size block of data, message digest and hash value from M. Message digest and hash value from M. Hash function H must be collision resistant on M. Hash function H must be collision resets on M. Must be infeasible to find M M dash not equal to M such that H of M is equal to H of M dash. So if we are going to be sending the message and the received message M dash, so both are equal or not, but we are going to be cross checking. So creating a small and fixed size of block of data, uh, block of data. So create a small and fixed block of data. So this is the message digest. You know what is the message digest? So something operation we can perform on message, and where we can. It is not a reversible process. Both the hash value. So what is a hash? Why we are performing a hash? The last unit we discussed it. What is a hash? So if it is unordered, different variable size of message is there, that message we are going to be send it as an output as a fixed size output from n. So hash function h must be collision to resistant on n, must be feasible to find n dash not equal to n such that h of n equal to h dash of n, h of n dash. So Sometimes it is if h of m is equal to h of m, then definitely it should be m equal to m dash. Then the message is not being modified. So such that both will be feasible to find both the hash of m, that is a something hash function we are going to be perform, that is equal to h of m dash. So when it is coming to the original message m and m dash, when both are equal, then we can say that that is not modified. Okay. So common message digest functions includes MD5, you know what is MD5, which produce 128 bit of hash, 120 bit hash. No? So each block of data, which contains 128 bit size, the fixed bit size contains, and SHA1, which outputs as 160 bits hash. Then we know another one is about MAC, message authentication code. What is message authentication code? A symmetric encryption is used for message authentication code algorithm. Simple MAC defines S of K of M, that is a sender key along with message is equal to function of K, comma H of M. We are going to be do the hash function for M, where f is a function that is one way on the first argument. The k cannot be derived from the function of k. So because of this collision resistance in the hash function responsible to the hash, no longer other message to create the same MAC. So such a pattern, we starting onwards we are saying that the hash function or message digest or MAC, both are we are using for verifying purpose only, it is not a reversible process. So it is only just to create for verifying only. So each and every message we have a similar MAC in the receiver side. When we have a both message, both sides we have a similar thing, then we have the verification process is completed. That is only see that a suitable verification algorithm, that is a V of k, M of a is equal to function k of a and a, that is equal to a. So that is an authenticator, we can give the authentication on the message. So then it is verified, then only we can have that particular authentication on that particular message sent by the sender. So note that the key is need to be computed both S of k and V of k. So the key is must be computed both sides. That is, for example, if you transfer key should be so that is verified, code should be verified both the sides. Anyone able to be compute can other computer and compute others also. So there another one is about digital signature. So based on asymmetric algorithm. So before the one is about based upon symmetric algorithm. Here based upon asymmetric algorithm. So we are going to be provide how the authentication means through the digital signature. We are going to be provide the authentication. Digital signature means so something general document how we are going to be signing. So the same thing we are going to do the digitally on the document, that is known as a digital signature. Based upon authentic asymmetric key and digital signature algorithm. So authenticator produce our digital signature. Authenticators produce the digital signature. So we generate the key that the person is going to be create that digital signature. In a digital signature algorithm, here also we have two types. One is signing algorithm, another one is verifying algorithm. One is a signing algorithm, another one is verifying algorithm. So here S of S, K of S is a signing algorithm, E of K of E is equal to verifying algorithm. So computable infeasible to derive S of K of S and from V of K V. So V is a one-way function. So KV is a public key and KS is the private key. KV is the public key and KS is the private key. See that? So in the previous, in a hash function, in MAC or in a hash function, we are going to be use the same key. See that K are same here. K are same. So that's only in a symmetric algorithm we are going to be use this message authentication code, or even if we want to find this hash function also we can do it. So if the keys are same, it is general, we don't have any key in a hash function, just we are going to perform the hash by using message by this and we are going to do this. Then here, for if an asymmetric encryption is there, so how we are going to be provide the authentication means by using message authentication code, we are going to be provide the authentication. For example, in asymmetric algorithm, how we are going to be provide. So based upon the digital signature, we are going to be provide this authentication. Okay. So the receiver here the two different keys are there. Consider the RSA algorithm is an example for this. So where we are going to be find out this one, the digital signature of message SRK of S n equal to HR not KS node N. So I think in the unit we were discussing about this RSA algorithm, how we are going to perform, what is the prime number, how we are going to perform all those things. So verification algorithm, one is the signing algorithm. So this is the signing message, this is the signing algorithm, this is the verification algorithm. So then authentication. Why the authentication is a subset of encryption? Another one is about why the authentication is a subset of encryption. A pure computation except RSA algorithm signature. Authenticator used to shorten than the message. So that all for example, if your documentation is there, if I'm going to be verified, is that every line I'm going to be do the verify? No. So all those things for example, by page we are going to be do one tick mark. Or one experiment we are going to be do one sign. Or total document we are going to be do one. So that is smaller than the message sometimes. Sometimes we want to authenticate but not confidential. So sign different models and can be no repudiation can be based upon the no repudiation. Authentication for digital signature and this no repudiation. So then another one is about key distribution. So delivery of symmetric key is a huge challenge. Yes, sir. So in a symmetric algorithm, we know that the shared key is going to be shared in between the sender and receiver. So this is a huge challenge. How we want to share that key. Sometimes done out of so it is not able to reach also. So asymmetric protocol shared on key ring. So even the asymmetric key distribution needs care of the man in the middle attack. So how the man in the middle attack? You know that man in the middle attack. So that is the sender and receiver is receiving message. In between the person is receiving the message and he is doing modification and is sending. So that time what is going to be happen? The receiver knows that that message is sent by the sender only. So that is a man in the middle attack. So see here. So something is writing and he is doing an encryption with some key. And some message is going to be done in between. The attacker is going to be use some different hacking is done, and is going to be changed the message and modified message and is going to be delivered. So such time the receiver knows that the message is sent by the sender only. So he is a different decryption algorithm which is used to run decrypt the message and he change the original message into a different form of message. Okay. So for that only here we have what wants a public key. So digital signature, who for who and what wants a public key. So digital signature will use the key. So public key is digitally signed a trusted party. Trusted party services proof of identification from entry and certified that the public key belongs to entry. So certificate authority are the trusted party. Their public key is included with web browser distributor. Public key is included web browser distributor. Once again. Okay, so the public key is digitally signed and trusted. The trusted party services proof of identification from entity and create that the public key belongs to entity. So certificate so here we were following some of the I think these digital certifications have you seen in the browser digitally certified digital signature certificates. One second I will show you if you take any browser how the digital signature certificates will be there and how it will be. Have you seen the browser? Any certificates will be there. Will show you. Have you observed sometimes third party cookies or for example any other digital certificates are going to be missing, so that's why we are unable to get some permissions like that. That is installation of browser. It is asking sometimes. For example, if you open your sometimes if you doing any online exams or anything, so sometimes it's showing it down. So your browser is not capable with your thing. So only that particular keys only it is particular browser only helpful to perform this one. So all the browsers are not supported. Have you observed that? So browsers are not supported. So like that, if we have information like this, so there we have the certificate authority is going to be accepted. So sorry, we are not seeing that. An example of this SSL, so that is secure socket layer thing. So insertion of the cryptography at one layer of ISO network model, the transport layer. So insertion of cryptography at one layer of the ISO network model, the transport layer. So secure socket layer, it's also called TLS, transport layer security, transport layer security. So cryptographic protocol that limits two computers to only exchange a message with each other. So very complicated with many variations. So used between the web browser, web server and browser for secure communication, credit card numbers like the server is verified with the certificates, ensuring the client is taking to the correct server. So asymmetric key is used to establish the session secure session key. So I think this is secure session key. For example, generally if you receive any OTP, for example, if you are logging and forget password, the OTP will generate. For example, OTP generate. And downside, if you read that OTP, something right, so it is valid only 15 minutes. It is valid only 10 seconds. It is valid only for 2 minutes. Like that, that is the meaning of session. Session means in particular after time the key is going to be expired. That OTP is going to be expired. So the bulk communication during session we are going to use. The communication between the each computer thus uses the symmetric key cryptography. So the crucial to identify the user correctly. So here the um, thing is crucially identify the correct users. So if the exact user is entering or not. So that's one each and every time it is going to be checked with your own personal identities. For example, your mobile number or your email ID or your, for example, thumb impressions. That is, for example, nowadays we are using mobiles. Everything we have a digitally sign something that is a fingerprint and face sensor also sensors all those things comes to identify and keep your data as to identify whether you are not protecting system depend upon your ID. So user identity must often establish through the passwords. What are the passwords? Or some patterns or some password. So anything that is a true password. So it considers to the specific case of either keys or capabilities. This also includes sometimes the head and of user attributes. Password must be kept as a secret. Password must be kept secret. So frequent changes of password. So use of non-guessable passwords and the long or invalid access attempts. So what is this frequent change of password? So as I told you, for example, I will show you if you don't know what is that, how it will come. Anyone having Andhra Bank internet banking? Andhra Bank internet banking, anyone know the Andhra Bank internet banking? I will show you that the passwords regularly change. So these are the very real time. We have to not only learning and we have to update it yourself also. For example, this is for example if you are operating your internet banking, so please check often you can change your passwords and you can please be secure. So that one I told you, sir, how much of my account is going to be carried out only 500 and 600 only. We are not using any multiple company. For example, I already told you the hackers identify your patterns, every pattern. When you are doing a bulk transaction. So for example, here today your friend asking, so I need to run for 1 lakh rupees. So such time is the attacker is attack what is going to be happening. So that's why each and every time we have to secure and we have to keep your passwords and we have to keep security properly to your so I will log in then only I will show you the internet. Now I will show you what is session time and what is login logs. See that? So for example, if I operating this, see that the session timeout in 0 hours and 5 minutes of previous session and logins. So these are the logs. So see that previous time when I was logging at 28/11/2020 at 3:10 p.m. I was logging in that time. So time is last valid login attempts is 21st 10. So that. So these are the preferences. So security settings. See that? So here we need to update password. Did you see that new updation? In a previous updation, it will shows that so your password is nearly it is 12 months old or 120 days. It is going to be expired. Something it will shows some lines over there. So preferences updated. So this is a valid time login. So this is uh, when is a particular login. So it is a problem. So we oftenly check this one. So whether I done it or not. So whether we have done or not properly. So in a last login I done or not. So oftenly we need to check it, these logins also. So then another one is usually we need to use usual patterns. What is, for example, if I simply give ABC, what is that? Maybe you will you, for example, your name is coming. So the same name you are going to use as a password. So that is so frequent use of non-guessable passwords. So for example, usually how, for example, if I find anything, so same if I find the name, the same name if I trying to enter that one. So that is non-guessable passwords we should give. For example, simply you can give a pattern 1 2 3 4. So anyone can first they will try 1 2 3 4. So that is such type of non-guessable passwords we need to keep. So and log on all invalid attempts. We have to check it all the logs. The password may be either be encrypted or allowed to use only once. So password must be always check it with the previous time you are using this password. You should not use the same password as next time. We need to change the password. That means we should not use the previous passwords next time. So implementing the security defense. So defense in depth is most common security therapy in the multi-layers. So security policy describes what means secure and vulnerability and accessibility. Where is the weak points are available? Vulnerability assessment compares the real state of the system and the network compared to the security policy. So then the intrusions detection, elevators to detect the attempt the successful intrusion. So signature based on and we have to detect that what are the spot difference between the normal behavior and different behaviors we can can detect the 0 day attacks. So false positives and false negatives in the problem and the virus protection. So implementation. Where are the implementations? So this way we are going to be talk in the forthcoming classes. Where we have to protect our system. So our main concept is system security. So where the system is going to be attacked, that's the places we need to protect it. Then auditing, accounting, and logging all the specific system network security. So you will see completely what is about firewall and what is the firewall systems. You will see that firewalls to protect the system and the network. So a network firewall is placed between the trusted and untrusted host. The firewall limits network access between these two security domains. The firewall limits network access between these two domains. So it can be turned as to. So turning allows to dissolve protocol to travel within allowed protocol. So that is HTTP. Have you remember HTTP and HTTPS secure hypertext transfer protocol? That is a telnet itself. The firewall is typically based upon a host name or IP addresses, and which can be used as so what is this HTTP mean? So simply I will show you one simple how the browser will be enabled with HTTPS. Okay. So for example, simply you can consider where we can get a HTTP. Second, I will show. So whenever if you are login with any system, other system, check with your browser with enable with HTTPS or HTTP. So HTTPS is the secure one. So my screen is visible to everyone. So I will show you one second. So always we can check it with the systems whether your system is enabled with the security or not. Generally we forget. For example, this is the URL. This is the URL. If you click and you can go to home button, see that the starting what is that is visible to everyone. HTTPS, that is secure hypertext transfer protocol is there. So it is secure. The S means secure. Always think that whether it is a secure transactions we are going to be through the URL based secure we are going to be doing. So everything. So the domains who are going to be maintained the for example this internet banking who is going to be maintained, they have to see about what where is the vulnerability, in which place the attackers are going to be attacked. For example, they are going to be through attack through the URL base. Then we have to do security for URL. They are going to be secure through the network. So what type of network we are going to be used? So if the network is not properly used, that's why we simply whenever we are going to be get a message from bankers, so don't use your internet bankings with the public networks. Have you heard that word? Don't use your internet banking through the public networks, or when you are in the untrusted networks, you should not use the networks like that. They will suggest, same way we have to see that how to protect that. The network administrators will check it whether what are the transactions are going to be done, and the which way how the transactions are secured. So once we talk about physical systems, we need to provide the security. Another one is about network we are going to provide. Through the network, how we are going to provide the URL, how we are going to provide security, all those things we have to see. Then a personal firewall software is layout given a guest can monitor and limit the traffic can be throughout the host. So application proxy firewall understand the application protocol can control them, that is SMTP, simple mail transfer protocol where you use that one. Then the system call firewall. So what is the system calls are there? System calls means what? Know that what is the system calls? So in order to wake up each and every button key plus what the call we have to send to that one. So instructions we are going to be passed to the operating system. For command, all those commands are there. No? If you read in operating system, we have known this one system calls on these things. So see this. This one is one network security through the domain separation via firewall. So domain name. What is the domain name? What is the domain name service? So the simple name how we are going to be used as a name for example Google.com. So generally it is for example it is something IP address. So it is mainly it is a problem to remember the number each and every time. That's why simply we are going to be give as a names to that particular service, that is the domain name service. Internet access company, so this is the firewall. So internet and the company computers, and for example we are using some servers through the firewalls. How we are going to be protected? They're going to be maintain this domain names, all those things. So the internet and some we are going to be access, the domain names are specifically verified or not, that verification is going to be done. So firewall, so something we are going to be given protection. So what type of things we are going to be enter into this, which are having a capacity of uh, that for example how we can for example is enter into that particular security, then only the wall is open or else it is going to be stopped. So like that we are going to be protect all those things. The computer security classifications. So US Department of Defense Security DOD so outlines the four computer securities A B C D. So D is the minimum security, and C is provides the uh, disgruntled protection through the auditing, and divide into C1 and C2. And C1 identifies the corporate users levels of protection, and C2 allows the user levels of access control. B all the properties of C, and however each object may have a unique sensitive labels, and B1, B2, and the various categories of this one. So Windows XP, how we are going to be provide security system based upon the user accounts. So each user has a unique secure ID. So login IDs and create access tokens, including security IDs, all those things, and special privileges. So every process gets copy of tokens. System checks tokens to determine if access allowed or denied. So how to perform uses a subject model to ensure that access security. and object subject to that track or message the permissions of each program that users runs, whether the particular user authenticated user are running or so. Sometimes, so for example, if you go to any lab, so we are asking to go to the user. For example, two logins are there, so user login and I lab and two logins will be there. So there we need to go to the particular login and we will provide the particular thing. If you are want to install, sometimes we ask, so you want to install through the administration permission or not. So sometimes in a client login, that is a guest login, if you are login, you are unable to install the applications. So if you click on application, it is asking whether you want to give a credentials, that is a that main admin username, that password it will ask. You want to get the password, then only you can install that things. Each object in the Windows XP securely is defined by the security descriptor. For example, the file has been security descriptor that indicates that access permission to the all users. So when we are creating the guest logins, so it is asking to whether how much permissions you have to give. For example, simple these permissions in the concept. For example, if you are install some other third-party app, we don't know what is the security. So it is asking whether you want to enable a camera, whether you want to access a contacts, whether you want to all those things. So be care with these allowing permissions to all. So then only we can provide the better security to all this. So that was the end here, and from next class we will see about how we are going to be secure these firewall securities, and we have some other security measures in the system level, how we want to protect all those things, that we will see tomorrow. And in IP security also, I think authentication authentication code and ESP. So encapsulation payload also we will not completely discussed. That we will discuss I think in the next class. Okay. Within 2 or 3 classes we will complete this also. Later we will go through the revision of all those things. Okay. So anyone having doubt, you can ask me.